Hi, today we are going to discuss about IGCSE question for the topic of permutations and combinations. For the first questions, there are total of 11 family members, including the dad and the mom, and 5 sons and 4 daughters. They are going for a tennis competitions where 6 members are needed, which are 4 male and 2 female. So we are looking at a number of different arrangements if there are no further restrictions. When there are no further restrictions, we go by category of gender, male and female, since we need 4 male and 2 female. So if we need 4 male, how many males do we have in total? That will be 5 plus 1, 6. Out of 6, we need 4, and 4 plus 1, out of 5 female, we need just 2. So 5C2. So that's the working step. And make sure you calculate this using your calculator. 6C4 times 5C3. C4 times 5C3. So it should be 150. Alright. Now we go on with the next questions. The next question with a little bit of constraint. The dad and the mom must be in the team. You must include them in a team. So to make sure they're included, so we're going to take them out for the total family members. The dad has to be included. That is 1C1 must be selected. And the mom also. So it's another 1C1 must be selected. It's very specific. The dad and the mom. And then you look at the male. How many males do we have? 4. We have 5 more sons. So out of these 5 more sons, how many more do we need? Because we need 4 male in total. One of them is the father, so we need 3 more from the son. So we put a 3 here. And how many female do we have excluding the mom? 4 daughters. So we put 4 here. And out of 4, because we need 2 female in total, since the mom is included, you need 1 more for female. So just 4C1. So this one is a very specific, it's a constraint and context based. Make sure you all figure out. Okay, because dad and mom must be included. So this is the working step. And what is the answer? 40. Right. So we go on. Okay. Now, this is the question. I put it here. It's easy to reference. Either the dad or the mom. Either one of them. The dad or the mom. One of them only. Not both of them. Just one of them. Either one of them is in the team, but not both. So I separate out into 2 different cases. The first case is the dad is selected. The second case is the mom is selected. So what happens if the dad is selected? Same thing, it has to be selected, then it's 1C1. Multiply. Okay, we look at the question again. Because the dad is selected, how many males left? Or 5 more sons. So we put 5. Out of 5, because you need 4 male, 1 is the dad, one of them is the dad, so you need 3 more for the male. You need 3 more for the male. And how many female left? The daughters, 4 daughters. Should we include the missus? No, you don't include the mom. Because if you include the mom, there's a chances that the mom will be selected. Because the dad is selected. So the mom should be excluded. So you don't include the mom during this female category. You only include the daughters. So only the 4 daughters, 4C, because you need 2 female and there's no female here so far. So you're going to have 2, 4C2. Okay, figure out the answer. Same thing here. If you go for the case number 2, you go for the mom, not the dad, then it will be 1C1. Multiply with the male. Since the mom is included, the dad should be excluded. So the dad is excluded, we're only considering the 5 sons. But out of these 5 sons, no longer 3 male, because we need 4 male in total. The dad is not included, so there's only 4 male. Right? It's not 3, it's 4. So it's different now. That's why we need to separate out, because it's different. 5C3, 5C4. And then the last one is the daughter. We have 4 daughters, so we have 4. But we don't go for 2 female, because we have the mom included, so we need 1 more. So 4C1. That's the idea. Okay, let's calculate and see what's the answer. 5C3 times 4C2, 60. You can also try first before you check the answer. 20. So the answer should be 80 lah. 80 in total. 60 plus 20, 80. Okay, we move on. Right. Okay, find how many 5-digit even number. So the keyword here is it must 5-digit, it must be even. So to make it even, the last slot you have to be is constrained. There's a little bit of criteria for the last slot. In order to make it even, I think you can only put either 2 or 4, right? 2 or 4, meaning you have 2 digits and you need pick 1, 2p1. The rest, because you have 5 digits in total, one slot has been filled. So you have 4 more digits left. So out of these 4 more digits, you're going to pick all 4 to be filled in the slot. So 4p4. 4p4 times 2p1. 4 factorial times 2p1 times 2 basically. So we should have 48. 48, right? Okay, then we go on with the next question. Find how many 3-digit number. 3-digit number, that's why only 3 slot, not 5 slot. Using the digit 1, 2, 3, 4, 5, same kind of digit. Okay, so this one is not 5p5, because even though you have 5 digits, 1, 2, 3, 4, 5, there's only 3 slot. So it should be 5p3. You need to have select 3 slot only. Out of 5 digits, you're going to pick 3. 5p3, that will be 60. Alright, so we move on. This one is a bit hard. Okay, try to understand the question first. So there are a man and 2 women. These are the women, WW. These are the men, right? Sit in a row of 5 empty chairs. So there will be a slot that is empty, but without anyone sitting on it. So it's a bit special. Now we want to find the number of ways can be seated if the 2 women must sit next to each other. The best way to understand this is to list out all. Because if you don't list out all, it's very hard to understand. Of course, there are more than one way to sort this out. I want to present you this because this is the easier ways to visualize it. So if you think about that, woman, 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 woman. Then whenever the woman sit here, the man can be here, can be here, can be here. The man can be here, 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 there, here, here, there. This is the 12 ways of visualizing. It cannot be more than this. Definitely cannot be more than this. The only one more way to visualize this is it should not be just 12, but 24. You know why? Because these 2 women, they can swap the place. Right? For every 12 cases here, the 2 women, they can swap the place. Swap, 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 swap. So there should be another 12 set, right? So the way you do this is you're going to have 12 times 2p2. Why 2p2? Because the 2 girls, they can swap their own place. 2 girls, 2 slot, they can swap 2p2. Or you can also understand if 12 times 2 factorial, because the 2 girls can swap. Or you can also write as 12 times 2. Up to you. But the answer must be 24. Okay, the answer must be 24. Okay, then we go with the next questions. The criteria now is all 3 people must sit next to each other. So I don't care whether it's man or woman. I regard it as people. So P, P, P. So 3 persons sitting like that. P, 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 or like this, or like that. Right? No other way, right? Because they must sit next to each other. So you're going to group them together next to each other. So if they are sitting next to each other, this is the real arrangement. So there are 3 ways to arrange it, right? But among these 3 persons, okay, they do. They can swap among themselves. So that is 3 times 3p3 or 3 times 3 factorial. Up to you. So the final answer should be 18. Alright, then we move on. For the photographer, take 12 different photographs. So there are 3 sunsets, 4 oceans, and 5 mountains. The photographs are arranged in a line on a wall. Whenever you see the keyword arrange or in a line, then is NPR, permutations. order matters. Right? So you're going to use P. Same things to digits. When you have to arrange something in a digit number, it has to be NPR, digit. But selecting member into committee, that is NCR. Arrangement doesn't matter. So this one is NPR. How many possible arrangement if there are no restrictions? No restrictions, we look at the total number of photographs, 12. 12, out of these 12, we are going to pick how many to be arranged. Or it is not state how many, it should be all. So 12P12 or 12 factorial. Your answer should be 479001600. Okay, 12P12. How many possible arrangement if the first photograph must be a sunset photo? The first one must be a sunset, and then the last one must be an ocean photo. Okay, then the one in the middle doesn't matter. There's no restrictions. The first one must be sunset. We have 3 sunset photo. Which one we're going to pick? We don't know. So we have 3 sunset. We're going to pick one, 3P1. And we have 4 ocean photo. So we have 4P1. Total, we have 12 photographs. 1, 2 photograph has been selected. So you have 10 more photographs left. Out of these 10 more, no restrictions, you're going to pick all 10. So that's 10p10. 10 factorial. Your answer should be 4354560. Okay, now we go on. Okay, these are the questions. This is the original question. In case you forgot, I put it here. 3 of the photographs are selected, so we need 3 only, not 12 anymore, but we have total 12 photographs. Find the number of different possible selection if no photograph of sunset is chosen. How do you make sure that the sunset photo will not be chosen? You take all out. You take all out. So you're going to take all this out. You have 3 sunset video, but you are going to take all out. So you have only 9 photographs left, right? So you have only 9. So here meaning no sunset. If no sunset, 12 minus 3, you have only 9 left in total. And out of 9, you need another 3. So if 9C3, you know why 9C3 or not? Because you are not arranging it into a line on a wall. You just select it for competition. So you don't go for P, you go for C. So 9C3. Arrangement doesn't matter in this case. So 84. Okay, and then now we look at the second one. Find the number of different possible selection is 1 photograph of each type. 111 is chosen. 111. So sunset. Sunset we have 3. So 3C1 because you need 1 from each. And then followed by ocean. You have 4 ocean. 4C1 you need 1. And 5 mountain. 5C1. So it's 3C1, 4C1 and 5C1. What do you have? 60? Actually, it's just 3 times 4 times 5 lah. 60. Then the next one. How many different 5-digit number can be formed by using the digits 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You have 6 digits, but you only need 5 digits to be filled. So if you look at that, you have 6 digits, you only pick 5 to be filled. So 6p5, 720. How many of these 5-digit number are odd? Okay, look at the criteria odd. To be odd, you only look at the last slot. The last slot, then which digit make it the odd number? It's going to be 3, 5, and 1, right? And 9. 1, 3, 5, 9. To make it odd, right? So how do you make it odd? Am I correct? How many of these 5-digit number are odd. So 1, 3, 1, 3, 5, and 9. Right? It should be 4, right? Correct. So 1, 3, 5, 9. 1 or 3 or 5 or 9. Meaning out of 4 digits, you only pick one, 4P1. So total we have 1, 2, 3, 4, 5, 6, 6 digits, and one digit has been filled. So you have 5 more. So that will be 5, because you have 5 more, 5P4. Okay, 5P4 times 4P1 should be 408. 1359. Okay, correct. How many of these 5-digit number 135689 are odd and greater than 60,000? Okay, I think there will be let's try and see first. To make it odd, it can be 1, 3, 5, or 9. To be more than 60,000, you go for 6 and 8 or 9. You cannot put 5, right, at the first slot. If you put 5 at the first slot, it could not be more than 60,000, right? It could not be more than 60,000. So you only go for 6 or 8 or 9. Okay, let me go up. 6, 8, 9. But they are crushes, the first slot and the second slot. The crushes are 9, right? If you put a 9 there, you cannot put a 9 over there. Correct. So if there are crushes, you have to take out the 9. Take out the 9 first. Okay. If you go for 6 or 8 at the first slot, you can put 1, 3, 5, 9 at the last slot. But if you put 9 at the first slot, you cannot put 9 at the last slot. So it's just 1, 3, 5. Two different cases. So if you go for 6, 8, that is 2P1. And then 4P1, right? And then the one in between, because we have 6 total in total, 2 slot has been filled. So it's 4 left, 4P3. Here is 1P1, 3P1, and same thing, 4P3. Let's figure out the answer. 2P1 times 4P3 times 4P1, 192. 1P1 is 1, so it doesn't really matter. 4P3 times 3P1, 72. So 192 plus 72, you should get 264. 264 should be your final answer. Okay, okay, now we go on to the next one. Okay, this one, whenever you have NC4 or NCI and NPR with unknown, you have to find the value of n, you have to use the formula. In this case, it's NCR, so we're going to use the NCR formula. Okay, let me write it up for you. So we have 45 multiplied by n factorial, NC4, NCR. So this is my n, this is my r, this is my r. Okay, equals to, this is my n, oh no, not yet, not yet. Equals to n plus 1 multiply, this is my n, this is my n, minus my r, and my r factorial. Okay, right? If you look at it this way. Before we expand it, I want you to know this is n minus 4 factorial. This is also n minus 4 factorial, right? Same thing, right? N minus 4 factorial. All right. If they are the same, then you can cut it off. Cut off, cut off. Okay, once you cut off, let's write it this way. 45 multiply with n factorial over 4 factorial. 4 factorial will be 24 equals to n plus 1 multiply with n plus 1 factorial over 120, 5 factorial. Before we move on, I need to remind you of this. Last time when we have 5 factorial, we can write it as 5 times 4 times 3 times 2 times 1. Right? But if you look at this, 4 times 3 times 2 times 1, this is actually 4 factorial. So I can also write 5 factorial as 5 times 4 factorial. Am I right? If you look at this again, actually I can also write as 5 times 4 times 3 factorial. Can you observe the pattern? Meaning, if I want to, I always start with n. If I want to expand it, I will just minus 1 to the next term. So 5 minus 1, I have 4. Minus 1 again is 3. So depending where I want to stop. If I want to stop at 2, then I put a factorial. You get the concept? So now, if I deal with unknown, think about that. You start with n factorial. I can also write as n multiply with the next term, u minus 1. So what happens when I give minus 1 to n? N minus 1, that's right. So we have n minus 1. If you want to stop, you put a factorial. But if you don't want to stop, you're going to write as n multiply with n minus 1. Minus 1 again, if you don't want to stop. Then minus 1 again will be n minus 2, that's right. And if you want to stop, you put a factorial. You also can go on, if you think like that, you can have n minus 1 bracket n minus 2. You don't want to stop, you go on, n minus 3 factorial. So it depends how you want to change it. So now you look at n factorial, and also n plus 1 factorial. We're going to do something on these two, right? Yes, that's right. We're going to do something on these two. So for n factorial and also n plus 1 factorial, which one is greater? We always change the greater value. N plus 1 factorial is greater, right? If this is greater, we're going to change this. How do we change this? Okay, you see, if I start with n plus 1 factorial, so how do I change this? Of course, I start with n plus 1. What is the next term? N plus 1, you minus 1, right? So n plus 1 minus 1 will become n factorial. If I want to stop, I put a factorial. If I don't want to stop, I go with n minus 1. So I can change n plus 1 factorial to be n plus 1 bracket n factorial. This one can be changed. Why do we change it? Okay, now I change it. Why do I change it? You will know later on. So I change to n plus 1 bracket n factorial. I change it so that I have the same thing on the left, I have the same thing on the right, same level. I can cut it off. It's easier that way. So once I cut it off, then it'll be very easy and simple. (45/24) equals to n plus 1 bracket n plus 1 over 120. You can multiply it using cross multiplications and then it'll be the same. Or you can just multiply by 5, so that is 120. And once you have the same value on the denominator part, you can ignore these two parts. Just take the numerator. 225 equals to n squared plus 2n plus 1 quadratic. So you are solving a quadratic equation. N squared plus 2n minus 224. Make full use of your calculator. 14 and negative 16. Make sure you show your working step. 14 and negative 16, n minus 14, n plus 16. And then you are going to reject the negative value and let it be just 14. Why? Because n is a number of objects. So the number of objects cannot be negative value, right? Cannot be negative value, it has to be positive. So you reject the negative value. So the next time you do this, make sure if you have the value of n in a negative value and n is the number of objects, you reject the answer for negative value.